Hello students, we have studied geology paper 1, FYBAC geology paper 1. The paper title is mineralogy and crystallography and the paper code is USGE 101. The paper title is mineralogy and crystallography. This subject has been divided into 3 units, unit 1, 2 and 3. Unit 1 comprises the mineralogy, unit 2 comprises the crystallography and unit 3 comprises the descriptive mineralogy. Today we have started the unit number 1. The title of the unit is mineralogy. What is the definition of mineralogy? The mineralogy is nothing but the branch of geology which deals with the study of minerals. Okay, means the study of minerals, scientific study of mineral is called as mineralogy, and it is one of the major branch of geology which deals with the study of minerals called as mineralogy. Okay, what is the definition of mineral? The definition of mineral is naturally occurring inorganic substance with a definite atomic structure and chemical composition called as mineral. The mineral has been classified into two groups: rock forming mineral and ore forming mineral. The rock forming mineral means the mineral, the majority of major proportion of present in a rock is called as rock forming mineral, and ore forming mineral means those minerals are economically valuable, means economically very precious metals and non-metals called as ore minerals. For example, hematite is ore of iron, chromium is ore of chromite is ore of chromium, then another is chalcopyrite is ore of copper. These are the mineral belongs to the ore forming mineral. And rock forming mineral means those minerals are major proportion present in a rocks called as rock forming mineral. For example, quartz like silica, feldspar, then mica, amphibole, pyroxene, garnet. These are the rock forming minerals. Okay, and based on the chemistry, mineral has been classified into two ways: felsic mineral and mafic mineral. The felsic mineral means those minerals having higher proportion of feldspar and silica called as felsic mineral, and mafic mineral means those minerals having the ferromagneseous content, means ferrous and magnesium content, more amount of ferrous and magnesium present in a mineral called as mafic mineral. The felsic mineral also called as salic mineral. Salic means silica rich, called as salic mineral, and mafic mineral also called as phemic mineral, means presence of ferromagneseous mineral elements called as mafic or phemic mineral, and those minerals having higher proportion of silica and feldspar called as salic mineral as well as felsic mineral. Okay, then mineral again divided into metallic mineral and non-metallic mineral. Metallic mineral means the presence of metal, higher amount of metals presence in a mineral called as metallic mineral. Like hematite is ore of iron, then chalcopyrite is ore of copper metal, then magnesite is presence of again iron. These are the metallic mineral. And non-metallic mineral means like halite, rock salt, rock phosphate. These are the non-metal, sulfide ores. These are the non-metallic minerals. Okay, there are different physical properties of the mineral. We today see one by one physical properties of the mineral. Mineral have different physical properties like color, luster, fracture, form, hardness, cleavage, specific gravity. These are the different physical properties of the mineral based on their physical nature of the mineral. Number 1, color. Color is naturally color of the mineral is called as color. We see the talc. This is talc. What is the color of talc? The talc is whitish, greenish white color. This is the talc mineral. Another one is gypsum. Gypsum is colorless. There is no white specific color. Glass type color is showing. Gypsum mineral colorless. Then another calcite. Calcite also white colored calcite. These are the color of the mineral. Then these are the fluorite. Fluorite is a violet colored mineral showing violet color. This is the natural color of the fluorite. Another apatite. Apatite is brownish colored mineral. Okay, apatite. Then orthoclase. Orthoclase is a light pink colored mineral. Orthoclase. Okay, these are the natural color. Again, quartz. Quartz is also again colorless. There is no white or yellowish color, showing colorless color. Okay, then topaz. This is the topaz. This is the white brownish colored mineral. Okay, then another is corundum. Corundum is again somewhat like brownish color. Okay, this is the topaz. Okay, these are the color. Another property is streak. What is the streak? Streak is a property of that mineral which rubbing on the porcelain plate. This is the porcelain plate. We rub a mineral on this plate and some powders are formed. This powdered color called as streak. Okay, this is the, we see one by one. This is the talc mineral. We rubbing on this porcelain plate and then form some powder. This, the powder color is white. Therefore, the streak of the talc is white. Then another mineral is gypsum. Gypsum, when gypsum is rubbing on this plate, then some powders are formed. This powder also white colored form. Therefore, it is a streak of gypsum is white. Okay. Then another mineral is calcite. When calcite rubbing on this porcelain plate, then form some powdered material. This is also white colored material. Okay. Then fluorite rubbing on this porcelain plate, then form some powder. We see the color of that brown color. The brown color. The streak of fluorite is brown color. Then apatite, the color of apatite is brown, and we see the streak of that particular apatite mineral is near to the white color. Okay. Then another one is orthoclase. The color of orthoclase is a light pink color. When this orthoclase rubbing on this porcelain plate, the form powder, the color of this powder is white again. Means the streak of orthoclase is white. Then another one is quartz. The color of the quartz is colorless. When these quartz are being on the particular porcelain plate, then form some powder. Powder, the material is brown color. Okay. Then again topaz. Topaz is one of the important mineral. When topaz are being on the porcelain plate, the powdered material is brown color. Okay. Then suppose corundum. The color of corundum is brownish. And when this corundum rubbing on this porcelain plate, the material is also brown. Therefore, the streak of corundum is brown. This is the another physical properties of the mineral, that is the streak. Third one, luster. Luster means the shining properties of the mineral. Luster is nothing but the shining property of the mineral. How much shine the material, the particular mineral. There are different structure, the different luster. The first one, metallic luster and non-metallic luster. Metal means the shining shown by the mineral similar to that metal. So those minerals are shows property, shining property of the mineral like metal, called as metallic mineral, metallic luster. For example, hematite, galena and magnetite is a example of metallic luster. Then non-metallic luster. Non-metallic luster means these are the various types of non-metallic luster is as follows. Number one, vitreous luster. In metallic luster, only one type, metallic. Those minerals are showing metal-like luster, metal-like shining, called as metallic luster. And another one is non-metallic luster. Non-metallic luster have different types: vitreous luster, pearly luster, silky luster, resinous luster, greasy luster, adamantine luster, and dull luster. We already sent these notes on your WhatsApp group and Google class. Please see this and compare the particular notes with the practice. Okay. Number one, vitreous luster. The shining shown by the mineral similar to that of broken glass. Broken glass, like quartz. What is the luster of quartz? Vitreous luster, like glassy material, called as vitreous luster. Pearly luster. Second luster, pearly luster. The shining shown by the mineral similar to that pearl. For example, biotite and muscovite. Biotite and muscovite is one of the example of pearly type of luster. I will show you mineral biotite and muscovite and biotite. Okay. These are the mineral biotite and muscovite. There are two minerals belong to the mica group mineral. These are the biotite and these are the muscovite. The biotite and muscovite both are showing pearly luster, means shining like similar to that pearl like biotite, and this is the muscovite. These both are the belongs to the pearly type of luster. Then silky luster. The silky luster is the shining shown by the mineral similar to that silk. For example, gypsum. You see the gypsum mineral showing silky luster, silk type. You see the silk type luster, shining of the mineral is silk like, called as silky luster. Another one is resinous. The shining shown by the mineral similar to that resin. Resin, you know resin. The resin-like luster shown by the coal. You know, coal is a petrified wood. Petrified wood means in Marathi the coal is called as kolsa. The coal showing the resinous type of luster. Okay. Another greasy luster. Greasy means the shining of the mineral show like grease. You know grease. For example, mineral again is showing greasy luster. Adamantine luster. The shining shown by the mineral similar to the diamond. Diamond-like shining property shown by the mineral called as adamantine luster. For example, diamond. In our laboratory there is no presence of diamond, but the actually typical luster of the diamond is adamantine. Then dull luster. Dull luster means the mineral has no shining. Then we say dull luster. There is no any luster called as dull luster. You see the mineral tall is dull luster. Okay, dull luster. There is no any specific luster called as dull luster. This is the third property of the mineral, that is the luster. Okay, another one is another property, that is the fracture. What is the fracture? The fracture is a definition of the fracture. The broken surface of the mineral is called as fracture. The broken surface of the mineral is called as fracture. This is the quartz. The broken surface, whether it is rough or smooth or conchoidal, irregular surface boundary of the mineral is irregular, called as conchoidal fracture. These are the another physical property of the mineral. There are different types of fracture: even fracture, uneven fracture, Hackley fracture, earthy fracture, conchoidal fracture. These are the different types of fracture. Number one, even fracture. Even means the broken surface of the mineral which shows smooth and flat surface, called as even fracture. For example, opal, very smooth surface is called as even fracture. And when called as uneven fracture, the broken surface of the mineral which shows rough and irregular surfaces. For example, orthoclase. You see the mineral orthoclase showing uneven roughness. Rough surface is called as uneven fracture. Again, also gypsum is also uneven fracture. Then quartz is also quartz is a conchoidal fracture because of the very convex structure called as conchoidal fracture. Okay. Another one is Hackley fracture. Hackley fracture means the broken surface of the mineral which shows needle-like structure. For example, mineral kyanite which shows Hackley fracture. Hackley, H-A-C-K-L-Y, Hackley fracture. Okay, this is the mineral kyanite, very bladed from, very needle-like structures are developed, called as Hackley fracture. Okay, another one is earthy fracture. The broken surface of the mineral which shows powdery appearance. For example, talc. You see your nail, you cut the talc mineral by nail. Okay, the powdery appearance of the mineral is called as earthy fracture. These are the example of earthy fracture mineral, that is the talc. Okay, another is conchoidal fracture. The broken surface of the mineral which shows convex and concave. You see the mineral quartz for fame. See concave and convex. The external body of the mineral showing convex and concave structure, called as conchoidal fracture. The typical example of conchoidal fracture, that is the quartz. Okay, these are the physical property of the mineral fracture. Okay, another one is cleavage. What is meant by cleavage? The definition of cleavage: it is the tendency of the certain mineral to break easily. It is known as cleavage in particular direction. It is the tendency of the certain mineral to break easily. It is known as cleavage. Okay. There are three different cleavage: one side cleavage, second side cleavage, and two side cleavage. And some minerals showing the absence of cleavage. Means, for example, quartz. There is no any direction to cut in particular planars. Therefore, the mineral quartz showing the cleavage is absent. Okay. Another one is again. Okay, topaz. Topaz is also absence of cleavage. Quartz is also absence of cleavage. Okay, the mineral. Then on the example of one set of cleavage, that is the biotite and muscovite. You see the biotite and muscovite, weaker planes is only one direction. The mineral cut by only one direction, layered mineral. therefore it is called as one set of cleavage. Again must provide the same weaker plane, this direction, there is no any direction, one direction, therefore it is called as one set of cleavage. Then second set of cleavage, the mineral orthoclase and plagioclase are example of second set of cleavage. Means the minerals are broken in two directions. For example, orthoclase, you see orthoclase are cut horizontally as well as vertically as well as horizontally, both direction, cutting the direction of the mineral is both direction, therefore it is called as two sets of cleavage. Another one is calcite. You see the calcite mineral, this is the calcite broken in three directions. You see vertical, horizontal and inclined. Again inclined, somewhere inclined also weaker planes, therefore the set of cleavage of this mineral calcite is three sets of cleavage. Means some of the minerals cutting in only one direction called as one set of cleavage, some of the minerals are cutting into two direction, one set, therefore it is called as two sets of cleavage. For example, the mineral orthoclase and plagioclase, feldspar. And another one is three sets of cleavage, means the mineral are weaker plane of the mineral in three directional, vertical, horizontal and inclined, therefore it is called as three sets of cleavage. For example, a mineral calcite. And some of the minerals are showing the absence of cleavage, there is no any direction, only grains are present in a mineral, therefore it is called as absence of the cleavage. For example, mineral topaz, mineral quartz are example of absence of cleavage of the mineral. Okay, these are the physical properties of the mineral: color, luster, fracture, streak and color, streak, luster, fracture and cleavage. One more physical property of the mineral, that is the hardness of the mineral. The hardness is defined by the Mohs scale of hardness. The Mohs scale of hardness. The hardness may be defined as the resistance which minerals offer to the external deformation actions such as scratching, abrasion and rubbing. The hardened property of the mineral called as hardness. Hardness of mineral is depending upon the chemical composition and atomic arrangement of the mineral. Okay. In 1822, Austrian mineralogist proposed that a relative broadly quantitative scale of hardness is called as Mohs scale of hardness. Assigning values between 1 to 10, the Mohs scale of hardness for mineral has universally adopted. In 1822, the Australian mineralogists, the Mohs, proposed that particular classification of the mineral based on the hardness property, and which is assigned from 1 to 10 scale: 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. These are the Mohs scale of hardness box proposed by the Mohs in 1822. Okay. The mineral tall showing the hardness 1. It is very softest mineral in the mineralogy. Therefore, it is called as assigned Mohs scale of hardness 1. And hardest to that tall, second one, gypsum. You see the gypsum and tall. Suppose you rub mineral tall on gypsum, not cut, only cut. But from gypsum you rub the gypsum mineral on talc, the mineral talc is cut down. Therefore, the talc is softest than the gypsum and gypsum is hardest than the talc. Means, therefore, the gypsum value is assigned by the Mohs is 2. Another one is calcite. The hardness 3 of the mineral is calcite and 2 hardness is gypsum. Suppose you cut gypsum by the calcite, easily cut. You see, this is the mineral calcite cut by the calcite mineral gypsum. Means the calcite is harder than the gypsum. Therefore, the calcite is hardness 3. Another one is fluoride. The hardness of the fluoride is 4. Suppose from fluoride you cut calcite by the fluoride. It is also see that the mineral calcite is softer than the mineral fluoride. You see, simply, very easily calcite cut by the fluoride. Therefore, the calcite is softest than the fluoride. Another one, apatite is harder than the fluoride. Okay, the hardness of the apatite is 5. See, the mineral fluoride is cut by the apatite. Therefore, the apatite is harder than the fluoride. Another one is orthoclase. The hardness of the orthoclase is 6 and hardness of the apatite is 5. Suppose from apatite cut by the orthoclase, it's seen that this suggests that the mineral apatite softest than the mineral orthoclase. You see, easily cut. Okay, another one is quartz. The hardness of the quartz is 7 and hardness of the orthoclase is 6. Suppose you cut orthoclase by the quartz, the plaques of the orthoclase will be removed by the mineral quartz. Okay, you see this. Okay, then mineral topaz is harder than the quartz. The topaz hardness is 8 and quartz is 7. You see, easily the quartz easily cut by the topaz. And another one is corundum. The mineral corundum hardness is 9 and mineral topaz is 8. Suppose you you cut corundum by the topaz by the corundum. Okay, you see, this is the plaque of the topaz cut by the corundum. Therefore, the corundum is harder than the topaz. Okay, and another one is diamond. Diamond is hardest mineral in the mineralogy. The hardness of the diamond is 10. The diamond is not cut by the corundum, but corundum is cut by the diamond. Therefore, the diamond assigned as a Mohs scale of hardness 10. These are the hardness scale box: the talc, gypsum, calcite, fluorite, apatite, orthoclase, quartz, topaz, corundum, and diamond. 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Talc, gypsum, calcite, fluorite, apatite, orthoclase, quartz, topaz, corundum, and diamond. A simple definition of this mineral: two girls can fight, opposite queen Taramati can die. This is the simple identification criteria. The two girls can fight, opposite queen Taramati can die. 2 means talc, girl means gypsum, 2 girl can means calcite, fight means fluoride, fight against opposite queen Taramati. Fight means fluoride, against apatite, opposite means orthoclase, feldspar. Quartz means queen, Taramati means topaz. Can die means corundum, die means diamond. Two girl can fight against opposite queen Taramati can die. This is the Mohs scale of hardness 1 to 10. These are the physical properties of the mineral. Another one more property is remaining, that is the specific gravity. Specific gravity means the weight differences of the mineral in water and in air. Suppose some of the minerals are weight of the mineral in atmosphere and weight of the mineral is what in water is different. The difference is called as specific gravity. G is equal to difference of weight of mineral in water and in atmosphere. That is the specific gravity. These are the different physical property of the mineral: color, streak, lustre, fracture, hardness, cleavage, specific gravity, and one more is form. Form means the particular shape of the mineral. Suppose talc is some of the mineral cubic form, octahedral, dodecahedral. Some of the minerals are different form, massive form. And these are the forms. Shape of the mineral is called as forms. Okay, these are the different physical property of the mineral: color, streak, lustre, fracture, form, hardness, cleavage, and specific gravity. And in next lecture we see the chemical composition of the mineral, how to identify the chemistry of the mineral. Okay, thank you.